In this video, we will practice solving trig equations such as this one. Throughout this video, I am going to assume that you have memorized the identities on this chart. At the very least, you should have memorized the three identities shown here in yellow. The blue and pink versions can be quickly derived from the yellow ones. So make sure that you can generate a chart like this one in about 1 minute. Now, I notice that we have sine and cosine. To have an equation that we can solve, it's important that we have one trig function, not two different trig functions. So, I'm going to try to make a substitution. Looking at the chart of Pythagorean identities, see how everything is squared? So when I see sine squared x, I know I'm going to find that on the chart. Well, sine squared theta anyway. So sine squared is equal to 1 minus cosine squared. So I should be able to make that substitution. Okay, so sine squared is equivalent to 1 minus cosine squared. So this is going to become 2 times 1 minus cosine squared x, and that's equal to 2 plus cosine x. If we do the distributive property now, then we have 2 minus 2 cosine squared x is equal to 2 plus cosine x. So now we have all cosine, so let's get 0 on one side and see what it looks like. So if I subtract 2 from both sides, these cancel out completely. So now I have negative 2 cosine squared x is equal to cosine x. Let's go ahead and subtract cosine x from both sides as well. Now these are not like terms, so I'm just going to put them side by side. So now I have negative 2 cosine squared x minus cosine x is equal to 0. Now, cosine is a common factor. Actually, before I even do that, before I pull out the GCF, I don't like the fact that this is negative in the front. That's sort of bothering me. So I am going to divide every term by negative 1, which is a legal move that I can make. I'm not changing the solutions, so this will be 2 cosine squared x plus cosine x is equal to 0. Alright, I'm just more comfortable with this. Now, the GCF is cosine x, so I'm going to bring cosine x out to the front. That's going to leave behind 2 cosine x plus 1 is equal to 0. So 0 product property, I will set each of these equal to 0. So cosine x is equal to 0, and 2 cosine x plus 1 is equal to 0. Solving this will give me 2 cosine x is equal to negative 1. Dividing by 2 gives me cosine x is equal to negative 1/2. Okay, so I'm just going to find the solutions for each one of these. Where is cosine equal to 0? Cosine of what angle is 0? Well, I'm pretty sure that's going to be a quadrantal angle, so let's look at those. Okay, over here we have the point 1 comma 0. Up here we have 0 comma 1. On the left side we have negative 1 comma 0, and at the bottom we have 0 comma negative 1. Cosine is the x value, so I want to know where is the x value equal to 0. So that's going to be here and here. Those x values are equal to 0. So that gives me two solutions so far. I've got x is equal to pi over 2 and 3 pi over 2. Okay, so those are two solutions I have so far. Now I need to keep going and see what I can get from this. Cosine of what angle is negative 1/2? Well, ignoring the negative side, I know that cosine of pi over 3 is 1/2. That tells me that pi over 3 is the reference angle. By the way, here's another chart of information that you need to have memorized, or at least you should be able to generate a chart like this in under a minute. Alright, so cosine of pi over 3 is 1/2. So pi over 3 is the reference angle. So I will draw a diagram of pi over 3's now. Alright, I've divided pi into 3 pieces, so these are pi over 3. Now, all 4 of these angles have a reference angle of pi over 3. The cosine of any one of them will be some kind of 1/2. It's just that these two will be positive 1/2 and these two will be negative 1/2 because cosine is an x value, positive to the right, negative to the left. Because we want negative 1/2, we want these two angles. So those angles will be the solutions. So the additional solutions are 2 pi over 3 and 4 pi over 3. Okay, that's it. So we have those 4 solutions to problem number 1. Okay, let's move on to problem number 2. Well, right away we have only the sine function, so that's great. So I don't need to do a substitution. All I have to do is get 0 on one side, so I will add 1 to both sides. So that is going to give me 2 sine squared x minus 3 sine x plus 1 is equal to 0. So in order to factor this trinomial, I'm going to think binomial times a binomial. So 2 sine squared x can only factor as 2 sine x times sine x. 1 can only factor as 1 times 1. Now inner plus outer must equal the middle. Inner, I have 1 sine x. Outer, multiplying those, I have 2 sine x. The middle is negative 3 sine x. I'll get negative 3 if both of these are negative, which would mean both of these would be negative. Negative 1 times negative 1 is positive 1. So this is how you factor it. Using the zero product property, I can find the solutions by setting sine x minus 1 equal to 0, and by setting sine x, well, that was 2 sine x minus 1 equals 0, and sine x minus 1 equal to 0. Solving this will give me 2 sine x is equal to 1. Dividing by 2 gives me sine x is equal to 1/2. Adding 1 to both sides gives me sine x is equal to 1. Okay, sine of what angle is 1/2? Well, I know the sine of pi over 6 is 1/2, so that tells me that the reference angle is pi over 6. So let's take a closer look. Alright, here's a diagram of pi over 6's. Okay, here are the 4 angles that have a reference angle of pi over 6. Sine is a y value, so these two angles will be positive 1/2, and the sine of these two angles will be negative 1/2. Because I want the positive 1/2, then I'm going to pick these two angles for my solutions. So that means x is equal to pi over 6, which is this angle, and 5 pi over 6, which is this angle right here. Now, the sine of what angle is equal to 1? Well, that sounds like a quadrantal angle to me. Alright, 1 comma 0, 0 comma 1, negative 1 comma 0, 0 comma negative 1. Sine is a y value, so we want the y value to equal 1. 0, there's a y value of 1, 0, negative 1. This is the only angle right here at the very top. So that gives me one additional solution, which is pi over 2. Okay, that comes from this part of the equation. So these are the three solutions. Alright, so that was problem number 2. Okay, taking a look at problem number 3, I see that we have all cosine, so that's great. I don't need to do any substitutions there. Also, I see that we already have 0 on one side. So we can really dive in with the factoring process. So I'm going to go ahead and shoot for binomial times binomial. 2 cosine squared x can only factor as 2 cosine x times cosine x. 1, alright, I'm ignoring the sign for now, 1 can only factor as 1 times 1. Inner plus outer must equal the middle. Inner, I have 1 cosine x. Outer, I have 2 cosine x. The middle is positive 1. I can get that if this is negative and this is positive. So that would mean this would be negative and this would be positive. Also, negative 1 times positive 1 is equal to negative 1. So this is correct. So I can use the zero product property to find my solutions. The zero product property says 2 cosine x minus 1 equals 0 will give me a solution or 2. And then cosine x plus 1, set that equal to 0, I'll find more solutions. So solving this equation on the left, I'm going to add 1 to both sides, so that's 2 cosine x is equal to 1. Dividing by 2 gives me cosine x is equal to 1/2. Subtracting 1 from both sides, I have cosine x is equal to negative 1. Now, the cosine of what angle is equal to 1/2? Well, that's going to be pi over 3. That tells me that the reference angle is pi over 3. So I'm going to just draw a quick picture of pi over 3. Alright, here are multiples of pi over 3. Okay, all of them have a cosine of 1/2 except these two angles are going to give us positive 1/2 and these two angles would give us negative 1/2. Cosine is the x value on the unit circle. X values are positive on the right, negative on the left. In this case, we want positive 1/2, so these two angles will be the solutions. So x is equal to pi over 3 and 5 pi over 3. Alright, so that's what we get from this little equation. Now, what about cosine? Cosine of what angle is negative 1? Well, that is going to be a quadrantal angle. So let's take a look at that. Here we have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. Cosine is the x value, so we want the x value to equal negative 1. So looking through here, here's an x value of negative 1. So that means this angle right here is the solution. So in addition to the list I've already got, I'm going to add pi, alright, because that's what this angle is, just simply pi. So these are the three solutions to this equation. Okay, so that was problem number 3. Let's go ahead and do problem number 4. For this problem, I see that we have cosine and sine in the same problem. That's no good. I want to have all one type of function. So I'm going to make a substitution. Cosine squared, alright, thinking of my Pythagorean identities, cosine squared is going to equal 1 minus sine squared. So I'm going to make that substitution. Alright, so in place of this right here, I'm going to put 1 minus sine squared x. Okay, and then you have the rest of it. So it's plus sine x is equal to 1, just bringing the rest of it down. So now I have all one type of function, all sine. I still need 0 on one side, so I would subtract 1 from both sides. That's going to give me negative sine squared x. These cancel out on both sides, so now I've got negative sine squared x plus sine x is equal to 0. Now when I'm trying to factor, I don't like having a negative in front if I can help it. And one nice thing about solving equations, because I have 0 on one side, I can always just divide everything by negative 1 and just change all the signs. It's completely valid. So this equation will now become positive sine squared x minus sine x is equal to, and 0 just divide by negative 1 is still 0. The only thing I've got going on here is a common factor, sine x. So I'm going to take that sine x and pull it out into the front. That's going to leave behind sine x minus 1. And I can simply use the zero product property and set each one of these equal to 0 to find solutions. Alright, adding 1 to both sides, then I have sine x is equal to 1. Alright, I think both of these are going to be quadrantal angles. So let's take a look over here toward the left. Alright, quadrantal angles. I have 1 comma 0, 0 comma 1, negative 1 comma 0, and 0 comma negative 1. So for the sine of what angle equals 0? Well, sine is a y value on the unit circle, so I want a y value that equals 0. So this y value is 0 and this y value is 0. So that gives me two solutions. So let's go ahead and write those down. So I've got x is equal to, and this is angle 0 and pi. So I've got 0 and I've got pi so far. Alright, this line is going to be sort of in my way. So let's do that again for sine x equals 1. Alright, same type of deal. Alright, So again, we're looking for y values, but this time we want the y value to equal 1. So here's a y value of 1, and that's it. So that gives us a third solution at pi over 2. So I've got 0, pi, and pi over 2. So these are the three solutions to this problem. Alright, I think this video is long enough with number 4 there solved. So I'm going to go ahead and stop this video here. I'm going to continue solving additional problems on the next video, so I hope to see you there.